Let's talk about rate of change. We could almost call this video Proportional Relationships, the sequel. Make sure that you know about proportional relationships before you watch this video. We're going to look at proportional relationships a little bit differently today. For instance, I'm going to give you some examples. 30 miles every 2 hours. This is when we're driving in our car, right? Or $4 for every 2 cupcakes, or even 5 stars for every correct answer. These are all examples of proportional relationships. They are all direct, never-changing relationships between two quantities. If I'm going 30 miles every 2 hours, then every 2 hours I'm driving, I'm traveling those 30 miles. Or for every 2 cupcakes I'm buying, I'm spending the same $4, right? Or for every correct answer, I'm still going to get 5 additional stars. Those are proportional relationships. In every proportional relationship, there's an infinite number of possibilities. Let me show you what I mean. For instance, here I've got my $4 for 2 cupcakes scenario. Here's my $4 and my 2 cupcakes. What would happen if I doubled both amounts, both the dollar amount and the number of cupcakes? What would it look like? I would then have $8 for every 4 cupcakes, right? All I did was double my amount. These are proportional. What if I tripled my original amounts, the dollars and the number of cupcakes? That would give me $12 for 6 cupcakes. These are all proportional. These are all really the same base quantity. I could even divide if I wanted to. I could divide my 2 amounts by 2, and that would give me $2 for every 1 cupcake. I need to be able to show all the possibilities for a proportional relationship. And I'm going to do that by graphing. Before we go on to our actual graphing, I'm going to throw in some vocabulary terms here. These are hugely important. Please make sure that they make it into your notes. There's 2 types of amounts in a proportional relationship. Okay? The type you can control and the type you can't. In our $4 for 2 cupcakes scenario, which part can I control most? The amount charged per cupcake or the number of cupcakes I buy? The number of cupcakes I buy is really the only part that I can control. The store or whoever I am buying those cupcakes from controls the cost. The one you can control, the quantity you can control, is called the independent variable. You get to independently choose how many cupcakes you buy. The one I can't control, which would be our cost, right, is called the dependent variable. The amount of money that I have to spend depends on how many cupcakes I choose. So independent variable, dependent variable, those are important things to know. When I make my graph, I'm going to want to put the independent variable on the x-axis, the one I can control the most, and the dependent variable on the y-axis. Next, I'm going to need to label my axes using a scale. Now, that means to put the numbers on my graph, and when I talk about scale, I need to make it appropriate and equal. Let me show you what I mean by appropriate and equal. If I have y values of 4, 6, and 12 that I need to put on a graph, I can't just use 4, 6, and 12. Notice how the distance between 0 and 4 is not the same as the distance from 4 to 6, and also not the same distance between 6 and 12. This is not an appropriate scale because these distances are not equal. I need to take that into consideration for the number of cupcakes too. This would be a more appropriate scale, right? So I'm going up by 2's on my y-axis. I can choose, since it's my own graph, and you can choose for yourself, just make sure that all of your numbers fit. I'm going to go by 1's for the number of cupcakes because I'm not going to want to go more than 9 cupcakes across. Now I'm going to put a few of my points on my graph and draw in my line. Notice how I have my 2 cupcakes for $4. I have my 4 cupcakes for $8, and I had my 6 cupcakes for $12. This is going to really help me out. I can find other solutions to this situation by just looking on my line. Notice how my graph crosses the grid right here. That tells me that 1 cupcake is going to cost me $2, or even up here where 5 cupcakes will cost me $10, or here where 3 cupcakes will cost me $6. Any point along this line is a solution to my scenario. That's what happens in a proportional relationship. I'm going to go back to that for just a second. Today we're going to talk about unit rate, of course. The unit rate is this point right here where x is equal to 1. I want to find out how much it will cost for only 1 cupcake or one of anything, depending on what kind of graph you have. That's going to be my unit rate. So if I want to write my unit rate down, I'm going to say $2. If I can get my pen to work, $2 per cupcake. This would be my unit rate for this scenario, whatever it is when x is equal to 1. So here I have another graph. I have a situation here where I have cost in dollars for my y-axis and gallons of gasoline for my x-axis. I'm going to look for points along that line to help me find different situations for this scenario and my unit rate. So if I notice here, 3 gallons of gasoline is going to cost me $15, and 6 gallons of gasoline will cost me $30. And my third point over here says that 9 gallons of gasoline cost me $45. So I can pick any point along this graph. For instance, right here, 5 gallons of gasoline is going to cost me $25. So I'm going to look for my unit rate. Remember, my unit rate is whatever happens when x is 1. So when x is 1, the point on my line is right there. That's equal to about $5. So what would that look like as a unit rate? I would write down $5 per gallon of gasoline. That would be my unit rate. It's pretty easy to find unit rate when you have a graph already made. If it's not so easy to find though, there is another way to find unit rate. You probably figured it out in that last graph already. But I can do this simply by dividing. So we're going to try that really quickly. If I have $24.36 for 3 pounds of something, I can do the division to find my unit rate. I'm going to take $24.36 and divide it by those 3 pounds. I get 8.12. That's going to mean $8.12 per pound. That's my unit rate for this scenario. If I have 252 miles that I'm traveling every 4 hours, I'm going to take that 252 and divide it by my 4 hours, and I get 63. That means that I'm going to have 63 miles per hour. I could write that as 63 miles per 1 hour if I wish. Same thing, but there's my unit rate. If I have 54 stuffed animals placed into 6 boxes, how many animals am I going to have in each box? 54 divided by 6 will give me 9 stuffed animals per box. This would be a unit rate. Make sure to write down any questions so that you can remember to ask me at the beginning of class. Enjoy. I'll see you tomorrow.